We are going to be looking at a normal approximation to the binomial distribution problem. Women comprise 80.3% of all elementary school teachers. In a random sample of 300 elementary school teachers, what is the probability that less than 3/4 are women? Step 1, interpret and define. In this problem, we're looking at a random variable x, where x represents the number of female teachers, elementary school teachers, out of 300. When we look at this problem, we see that we're looking at a total of 300, a sample of 300. So in this problem, n is equal to 300. The true population proportion of the number of women is 0.803. And Q is going to be our probability that they are not a woman. So that will be 1 minus the probability that they are a woman, or 0.197. The question we're looking at, what is the probability that less than 3/4 of the 300 women, or of the 300 teachers, are women? So let's do that math. 3/4 of 300 is 225. So we are looking at the probability that x is less than 225. This looks like a binomial distribution. So this is going to be the probability written as it would be for the binomial distribution. Now that I have my problem defined, I need to do step 2, which is check. The two things I need to check, my first check is, does this meet the binomial distribution requirements? Here are those requirements. I need a fixed number of trials. Do I have a fixed number of trials? Yes. In this case, I'm looking at a sample of 300. So 300 is my fixed number of trials. Do I have 2 outcomes? Yes. They are either female or they are male, as we have to assume in all of our statistics problems. So yes, there are 2 outcomes. We've met this. Are the trials independent? Yes. The population of elementary school teachers is so large that by selecting one with or without replacement, it's not going to change the probability of a subsequent choice. So then the probability of success stays the same. Yes, my probability of success stays the same at 0.803. So yes, this is a binomial distribution. The next thing I need to check is, do I meet the requirements for a normal approximation to the binomial distribution? The first requirement is that we have a binomial distribution. So here we're checking normal. So here I have a binomial distribution. That worked. So yes, I do have a binomial distribution. Now we need to check these 2 factors, NP greater than or equal to 5 and NQ greater than or equal to 5. So NP is going to be, let's see, 300 times 0.803, which works out to be 240.9. So yep, that works. And NQ is 300 times 0.197, which works out to be 59.1. So yes, this works. Therefore, yes, we can use the normal approximation. So that works out well. So that's our entire step 2 of checking. Step 3, finding the parameters for the normal distribution. So now that we're assuming that we're going to use an approximation of normal, we need to find the parameters of our problem. The parameters for a normal distribution are mu and sigma. For a binomial distribution, we found that the mean, or the expected value, is n times p, which we've already calculated up here. So that's 300 times 0.803. We find the mean to be 240.9. Remember, we round to 1 decimal more than the given information. So then our standard deviation is the square root of NPQ, or the square root of 300 times 0.803 times 0.197, which, if I do that math on my calculator, I get 6.9. So I'm going to kind of bubble these because this is important information here. So we're going to need to keep these in mind as we work through our problem. So now that we've finished finding our parameters, we're going to actually go through and draw our distribution. Before I actually get into drawing my distribution, I need to keep in mind this correction factor. So the idea of a correction factor, the correction factor comes because this probability that I'm calculating is for a binomial distribution. But the value, so the value of my x is 225 for this binomial distribution. But because I'm using it as a continuous, 225 is really 224.5 all the way up to 225.5. We take 225 to be this range of values. So to use my correction factor properly, my binomial probability of x is less than 225, I need to convert over into a normal probability, and that becomes the probability that x is less than 224.5. So this is actually the probability that I am going to be calculating. And that's what I'm going to draw in my picture. So now I need to draw a normal curve. So here is my normal curve. And this normal is a distribution of x's that are approximately normal with a mean of 240.9 and a standard deviation of 6.9. Now that I have those, I'm going to mark my mean of 240.9, and I am going to represent this probability on my normal distribution. So I want the probability that x is less than 224.5. 224.5 is going to be to the left of my mean. So the mean is 240. 224.5 is somewhere over here. And that is going to be, I'm interested in this area here. This area here is the probability that x is less than 224.5. That's the area I'm going to be finding. I like to draw my standard normal distribution below. It's got a mean of 0 and a standard deviation of 1 with this special z star. Now that I have drawn my picture, it's time for me to calculate. Yay, math. All right, so what am I calculating here? Well, one thing I need to do is I need to find my z-score. So let's start by writing my formula. The formula for a z-score is x minus mu divided by sigma. The x value I'm looking at is the x value that's important in my probability. So that's 224.5. The mean is 240.9, and the standard deviation is 6.9. If you go to your calculator, which I've already done, we find that this z-score value is negative 2.38. Remember, round your z-scores to 2 decimals. Areas, we want about 4 decimals. Z-scores, we want 2. So now that I have this z-score, I found my z-score, now I need to find this area under the curve. So I'm looking for the probability that x is less than 224.5. This is the same thing as saying that I'm looking for the probability that z is less than negative 2.38, because in the x world, my variable is 224.5, and in the z world, that translates to be a value of negative 2.38. So this, I'm basically just converting. 224.5 in the x world is negative 2.38 in the z world. So these are equivalent statements here. So when I'm calculating that on my calculator, that is normal CDF. My left limit is negative infinity, which we don't have, so that's negative 1e99. And my right limit is going to be z star, which is negative 2.38. I'm going to include a mean of 0 and a standard deviation of 1. So I go into my calculator, normal CDF, negative 1e99. And the right value is negative 2.38. And I get 0.00866 as my value. So this is what my calculator gave me. Now, I've finished the problem. I've gotten all of the work right. The last step is I need to translate it, because most people who are interested in these problems or don't really know what I'm doing with statistics. So here we go. My question said, what is the probability that less than 3/4 are women? That's the question I need to answer. So to put this into words, I'll say the probability that less than 3/4, so the probability that less than 3/4 of 300 elementary teachers are women is about 0.87%. It's super unlikely. This represents a complete problem with all steps.